Today we're going to talk about geometric sequences, page number. Oh, sorry. So the goal today is we're going to show you what's up with geometric sequences instead of arithmetic. And yep, what's up with that? So let's roll through. This is just some kind of fun little example of a bungee jumper and its bounces and stuff. But we're just going to keep plugging away and talk about the difference between a geometric sequence and a arithmetic. Is a geometric sequence is one that is multiplied by a number each time. Arithmetic is added by a certain number each time. So we just got done talking about arithmetic sequences. I'm going to add a page here and just do some scratch work. So I'll just make up some arithmetic sequence. Let's say 5, 8, 11, 14, 17. Is that arithmetic? Yes, because it's plus 3 each time, right? Okay, so that's what we've been doing. That's arithmetic. All right. Right now, we're going to do a little something different here. We'll do like 4, 12, 36, 108, dot, dot, dot. Okay. This is not arithmetic because if you go and find all the differences here, if you're going to check, like, I wonder if this is arithmetic or not. And then say, like, okay, plus 8 plus bum, bum, ba-dum. It's not arithmetic. Doesn't go up by the same amount each time. You can't add. All right, well, you know what? It's actually a times pattern. It's times a number. So this is times 3 times 3. Each successive term in the sequence is multiplied by 3. So when you're timesing to find the next number in the pattern, that is a geometric sequence. Okay, so that's the difference, is this is a geometric, and this one up here when we're adding is an arithmetic. And so now we're going to add geometric to the mix. Some differences here. This plus 3, we called that the common difference. In geometric, this times 3 is called the common ratio. So it's the same concept, but a little different name there. Okay. All right. Sometimes the arithmetic sequence it doesn't seem like you're adding, it seems like you're subtracting, doesn't it? So let's just say we were going backwards here. 17, 14, 11, 8, 5. Okay, now we're not adding. Well, you're kind of adding. You're adding a negative 3, right? You're adding a negative 3. You're adding a negative 3. Okay, so in geometric, it's the same kind of thing. You might be getting smaller. So let's say we have like, I don't know, 50. Let's see here. 10, 2, 2/5. Okay, they're getting smaller. So they are dividing, but you're not going to go and say, oh yeah, divide by 5, because 5 is not the common ratio. So what is the same as dividing by 5 is timesing by what? A fifth. So if this class is so large that it's hard to keep under control. So it's times by a fifth. So if you are timesing by a fraction that's less than 1, your sequence is going to be decreasing, right? It's getting smaller. All right, let's look at some examples. Here you want to determine, hey, is it geometric? Is it arithmetic? This one is going down by 7 each time, so it's added to negative 7 or subtracting by 7. So therefore it's arithmetic with a common difference of 7. Okay, so just an example there from the book to look at. Here is the general rule for a geometric sequence. So a geometric sequence, because you're multiplying by a common ratio each time, we are going to utilize exponents to shorten this up and write a rule or a formula or whatever you want to call it for the nth term of a geometric sequence. So let's just look at an example. Let's say we start at 5 and we times by 3. So times by 3 would be 15, 45, 120 and 15 would be what? 135. Is that right? I think so. Times by 3 again, that's going to be 390 and 15. So what is that? 405. So on and so forth. What's the common ratio that I multiplied by? 3. So that was times 3. So now, if you think about generating a rule for any term, a sub n would be, in this case, what's the starting point? 5, right? 5 is a sub 1, times the common ratio, which is 3 to the n minus 1 power. That right there would be like your general rule for this particular geometric sequence. So you start at 5 and you multiply by 3 however many times minus 1 to get that term. Because you started at the first one, you know. So if you want to find the first one, which is 5, let's say you want to find the first one, then you put 1 in for n. 3 to the 1 minus 1 power is 3 to the 0 power is 5. It's 5. You know what I mean? So if you want to find the fourth one, which is this one, right? You put a 4 in there, and you take essentially 5 times 3 times 3 times 3, which gives you 135. So the formula, just for the record, one student just said, "Oh, that's so cool," which it is. But yeah, so there, that works for any term in the geometric sequence. Yeah. Well, so to solve for the common ratio, if you're given a sequence, you just take any term. So if, let's say it says, hey, this is a geometric sequence, you take any term divided by the term before it. So like this would be like 45 divided by 15 equals 3, right? That's how you find the common ratio. You could do it for if they say or state, hey, this is geometric, you can take any two terms and divide the one on the right by the one on the left, and you will get the common ratio of 3 every time. If you don't, it's not a geometric sequence. Okay, so taking a look at, here's an example of that. It says find the 7th term of this geometric sequence. So in order to find r, it tells us it is geometric, so you can take any of the numbers. I'll pick the smallest one. Take 12 divided by 3, you're going to get 4. So your r is 4. That's how they get 4. There might be gaps, and so if there would be a gap, let's just say, for example, we were doing this problem, but they didn't give us like those two. I think that's what you're saying. And so I was like, okay, I got that and I got that. Then you would just do the same strategy we did with arithmetic, and you'd use a general rule, which is a sub n equals a sub 1, let's see, times r to the n minus 1, right? But in this case, we know a sub 4 is equal to a sub 1 times r to the 4 minus 1. And then you would just solve for r. So a sub 4 is 192, a sub 1 is 3, and it would be r to the 3rd. So now this is just solving a cubic. Divide both sides by 3. You're going to get r cubed is equal to, what is that, 64? How do you get rid of a cubed? Cube root. So the cube root of 64 is 4. Neat, hey? Same thing, you just plug in. Cough button. All right, so that is, there's an example you can look at from the book if you want. We'll do one from scratch here. Here we have a geometric sequence. How do you know it is? Because they tell us it is. Okay. And so then you look at it. What is the R? R is equal to, take any term and divide it by the previous term, and you'll see that it's timesing by 10 each time. So R is 10. So if you want to find the 9th term, say we go a sub 9 is equal to a sub 1 times R to the 9 minus 1. But we know R now, and we know a sub 1, so we can substitute those in. 0.001 times 10 to the 8th. 10 to the 8th means it moves a decimal 8 to the right, which would add 5 zeros on to the end, giving us a value a sub 9 of, I believe, 100,000. Ka-chow. Yay? This next one I don't think you have in your notes, but we can do this one. Anyway, it's decreasing. And so if you were to take these big honking numbers, like 282, actually, let's be smart. Let's pick one at the end. Let's go with, hello, 823,543, and we divide that by 4,801. What you end up getting is 1/7. So the R is 1/7. It's a fraction. Notice it's a fraction. They're decreasing. So if you want to find the 15th term, a sub 15 is equal to a sub 1, which is 1,977,326,743 times 1/7 to the 14th power. Why, this isn't hard? Because they're big numbers. It's just big numbers. So then you just plug it in your big calculator. And you go 1977, 326, 743, parentheses, 1 divided by 7 to the 14th power. Ta-da! Ooh, pretty small number here. 0.003 if I round it a little bit. You got that? Nice job! Review. I'm going to leave the review up to you. Huh? Okay, because I want you to give you time to work here. So, because we need to get serious about our working in here. So that's all for today. We have a partner quiz tomorrow. I shouldn't have said that because then next year they're going to be like, how come they had a partner quiz? And then I'll just be like, because no one's going to watch us. All right, that's it. Under 15 minutes, under mark, set, go.